Yeah, I'm fine. Right, let's go ahead. So last thing we started with this momentum conservation. Let's go ahead with more problems. So we have a smooth horizontal rod. Fixed rod. So on this rod, we got a ring of mass m. This ring is tied to a ball of mass 3m. This is a string of length L. So when you release this, what will happen? The ball will start falling down. In this process, it will start pulling the ring also. The ring will come somewhere here and the ball would become like this. Basically, the tension will pull the ring. Eventually, the ring becomes vertical. Ball becomes vertical like this. So find the velocities and tension in the string when it becomes vertical. Let's get this. I hope the picture is clear, everyone. Let's see how will you proceed with this. And others, do keep your cams on. The ring is free to move. Why is the ring fixed? I showed you the picture also, Naresh. Hari. Does it look like the ring is fixed after 3 pictures? Okay. Try one more minute. Give me the tension. Let's see. 27 mg. That looks quite a big value, right? 9 mg by 2. Let's see, that looks reasonable. So first thing, this thing is clearly a conservation. Mass m, 3m. How do I know? This is state 1. And you're saying find the velocities at the lowest position. What did I say? Whenever you hear the words, find the speed there, find the maximum position. So you're only bothered about the final state. Now, looking at this, the masses are not equal. So I'm pretty sure velocities will not be same. Let this be V1, let this go with V2. Since there are no horizontal forces, horizontal momentum is conserved. Initial momentum is 0, 3m V2. So we get V1 is 3v2. Next thing, conservation of energy. So how much does this thing fall? The length is L. So loss in potential energy is equal to gain in kinetic energy. The loss in potential energy will be 3 mgl. So and gain in kinetic energy is half mv1 square. Half 3mv2 square. This will be 3gl. This would be 9v2 square. 3v2 square by 2. That will be 12 by 2, 6. So we get gl by 2 curve root. That's your v2. Check. And v1 will be root over gl by 2. Next thing, you're asking for tension. Any doubts on this? Check your conservation, see where it went wrong. Now, the second part. You want the tension, so you have to draw an FBD. So where will you draw this from? Remember, the ring thinks it is going in a circle. So observer is on the center, on the ring. So when you want to use a centripetal acceleration, what is AC? AC is nothing but velocity with respect to the ring. So tension, your own weight 3 mg. And since you're going in a circle, you'll experience a centripetal acceleration, which is V relative square by L. What is V relative square? V1 plus V2. And how much is V1 plus V2? V1 plus V2 is 4 GL by 2, 16. That will be 8G. So this will be tension minus 3mg is equal to 3m into acceleration. Yeah, it looks like 27 is the answer. Check. So if your center itself is moving, you have to take area relative. So momentum, conservation of energy, and then NLM, and then circular motion. This is kind of similar to this problem actually. The wedge is going back and the ball is going forward. Here the ring is going forward, the ball is coming down. It has similarities, even though the whole picture looks different. Have a look at this. See the calculations. Anyone is not clear, please ask. Clear with this? Clear, na, Anvita? Shaurya? Vanchika? Vedika? Clear with this? Next thing. Next one is a good one, right? This will be a proper advanced paragraph question. Top view. So on a smooth floor, you kept 3 identical balls. Let's say this is B, this is A, this is C. Right? So these are 3 identical spheres of mass m placed on a smooth floor. Then what you did, you kicked the middle ball with speed u. Only the center ball is given speed u. If you do that, what do you think will happen? After some time, B will come somewhere here. No, wait, it's not like this. Let me give it like this. Let this be like this. A and B are horizontal. Now, if you kick the center ball, what will happen? B will come little forward up. But in this process, A and C also will start moving. They'll start bending like this. B is still going up. Now C, A and C are also moving. Then eventually your picture becomes like this. A, B, C, right? They'll come in a line like this. Are you getting how will the motion be? If you took 3 balls in a line connected by strings, and if you kick the center one, can you see how will that V shape look like? The center, if you look at the screen, right? If this is like this, as the center is moving forward, you can say as the center is moving forward, the 2 edges also will keep coming closer, isn't it? So the collision would be something of this sort. Initially, that's flat. As you're getting close, they will collide. So this is like A and C, they're colliding. I hope the picture is clear. So let this length be L. Let this length also be L. Right? So the ball is given as shown. Ball B is given speed u. So what will happen as B starts moving, A and C come together. So the first question, find the velocities of A, B, C. Just before A and C collide. So as they come closer, A and C will collide. So just before A and C collide, what is the velocity? Find the tension in the string just before A and C collide. Let's try this thing. Let's see how we do this. The second one is a really good one, B part. This would be an advanced paragraph question. I hope everyone is clear with the scenario, how the things are moving, how is the picture. Think I'll give it 2-3 minutes for the first part. Let's get the speeds. That is still doable. That is still in your range. B is a little different though. Nere area. Missing something more. And then find the remaining. Now the question is velocities of ABC. Why are you telling me the easiest ones? You're like that kid who goes to the pizza, eats all the toppings, and leaves the pizza. You already have the picture. I'll give you a hint here. When these things are moving, you guys are forgetting something. A and C just don't have a vertical velocity. They also have a. This guy is V. A and C will also have Vy and Vx. Think about it. Without Vx, why will they come closer? Because the tension is this way. The tension is pulling them at an angles. A and C will have two components of velocity. So the tension is this way. So just before collision, the velocities will be like this. Vy. This will also be Vy. This will also be Vy. This will be Vx and Vx. Why will all of them have same Vy? Because the length of the string is constant, string constant. Since the string is tight, they'll have same vertical velocity. So when the system becomes vertical, straight line, since string is tight, they will have same vertical velocity. On top of it, A and C will also have horizontal velocities. There, your picture will look like that just before collision. Okay. That looks right, Samyak. Nee, Vanchika. Got the picture, everyone. So, yeah, let's conserve momentum. So, in the vertical direction, what is the momentum? Mu is equal to mvy 3 times because there are 3 of them. So, vy is equal to u by 3. Horizontal momentum is not required. Both are equal anyway. What else is conserved? Energy. Because the floor is smooth and there are no other forces, energy is also conserved. This is my state 1 and this is my state 2. Energy in state 1 is equal to energy in state 2. Initial energy, it is only kinetic energy, half mu square. Since all of them are on a smooth ground, there is no gravitational potential energy. This will be half m vx square plus vy square into 2 times because there is a and c. This is for a and c. Plus half m vy square for b. And vy is u by 3. This will be 3 by 2 mvy square, which is u square by 9 plus mvx square. That would be This will be like how much? This is u square by 6 of mu square by 3. So Vx will be u by root 3. Check. So that means this A and C, this is going with u by root 3 horizontally, and it is going with u by 3 vertically. A is also doing the same thing. A is going with u by root 3 and u by 3 like this. B is going straight with u by 3. Check the picture. That's not the answer. I hope all got the velocities. Now how to find the tension? No, you can conserve Vedika, but kuch nahi milega na extra. Dekho na. Initially, what is the momentum? 0. Finally, what is the momentum? mvx I cap minus mvx I cap. They'll cancel na, so 0. You'll just get 0 is equal to 0. So there is of no use basically. The moment you wrote Vx and Vx equal, you actually conserved horizontal momentum. How do we find the tension? Think, I'll give you a minute. It's a pretty good one. Near area. They're in a horizontal plane. I said, no, they're on a smooth floor. The particles are on a smooth ground. So there is no gravity. So they're placed on a flat surface. Mg, see here, there is no gravity only. Sure, listen. This is important. Huh? There are a few things here. So if I actually ask you how are A and C traveling, what will I say? If you look at C ka motion, it looks pretty weird actually. This C, right, as B is going, it is not going in a circle. It's going up also. It is going in some pretty weird curve actually, right? So, but there is one person who thinks it's going in a circle. Who thinks it is going in a circle? If you take the observer and make him stand on B, since the length of the string is constant, I'll not draw A. Okay, so this person will think C is going in a circle. Do you guys agree with that? In the ground frame, C is not going in a circle. C is going in some weird path. So an observer, so with respect to B, C goes in a circle. So if you want to use your centrifugal force, you have to go in a circle, isn't it? So here C goes in a circle. And if you want to use a mu square bar formula with respect to B, that means the observer is standing on B. So if you ask this person, boss, what is the velocity of C? It will say it is going with Vx because both have same vertical velocity Vy, it will cancel off, which is u by root 3. So now if you ask to draw the FBD, right? Now, the mistake people do is this. They think B is at rest, great, but you're forgetting something. Even B is decelerating. So if you draw the FBD of B, on B, there are two tensions, tensions. So B itself is decelerating. Think about this. B ka initial speed was U, P ka final speed was U by 3. That means B is slowing down, there is a deceleration. So 2 times tension is equal to mass into AB. This is one equation. That means B is a non-inertial frame. So the observer standing on B, B is a non-inertial frame. And if you're keeping observer on a non-inertial frame, you have to apply a pseudo force. So now when you draw the FBD of C, now what are the forces? Tension. That's it. There's only one force. Since you're going in a circle, there will be a centrifugal force, which is mvx square by L. But since you're standing on B, there is a pseudo force, right, which is mass of the body into acceleration of B. This is your linear pseudo force. Because the observer is standing on that. This is your centrifugal force because you're going in a circle. There are actually two pseudo forces. If you actually go back to the circular motion, this thing is d square r by dt square, that one. Let's not get into that. Got this? So now, if you draw the FBD here, tension plus m into AB is equal to mvx square by L. And what is m into AB? 2t. So this will be 3t. What is Vx? U square by 3L. Tension will be mu square by 9L. The most common mistake is people will not write this MAB. You write the centrifugal force. But tell me one thing, when you write centrifugal force, you should go in a circle, and B thinks you're going in a circle. Means you place the observer at point B. But the B itself is decelerating, so you'll get one more pseudo force. Are you getting the difference there? One of the most common mistake, people don't realize this MAB. They write T is equal to mu square by L, and that will not give you the answer. Yeah. Check. So there are two pseudo forces. Centrifugal force since you're going in a circle, and since B is standing on the body, you have a linear pseudo force. Any doubts on this? That's what makes the second question really good. You can see we are using circular motion pretty extensively. Circular motion, NLM, momentum, energy, 4 different things we are using at a time. Next thing. Next thing. Let's see one more. This is also the top view, meaning you're placing this on a smooth ground, so there's no gravity. So don't worry about the effects of gravity. So we have a ball of mass m. You tie this with a loose string. This is also mass, let's make it 2m. So this is a loose string whose length is 2L. But the distance between the balls is L. So this whole setup is placed on a, so there are two balls here. Let's call this A and a B. Smooth floor connected by a string of length 2L. The distance between them is L only. Now what you did, you kicked the ball A with speed U. So only A is given speed U. So what will happen after some time? A will come here, but remember string is still loose now, so B will not move. Then A will come here, then the string will become tight. You're getting how the picture will go? Till the string becomes tight, B will not move. Find the velocities of the balls just after the string becomes tight. And then find the tension in the string when the string becomes tight. I hope Aaron is able to visualize the picture there. Right now, everyone. Srihari, clear with the picture? Yashvi? Clear? Pratyasha? Clear, na? Devanshi? Rudransh? Try. Let's find the velocities first. How do we do this? Think, think, think. Hmm. √3 आ रहा है क्या रे? Root नहीं आएगा रे आर्या. You can't conserve energy here. When the string suddenly becomes tight, it's like it loses energy there. It's like a jerk. But how did you get √3? Maybe because of that cos 30 होगा. Maybe you're right. Let's see. Hmm, I think you're right. Give me the tension.
Sir, like the immediate tightening of the string or after some time?
Immediate tightening of the string क्या होता है? What
मतलब
did I write there?
just when, okay, I
It
got it.
doesn't matter. After the string becomes tight, the tension is constant. Nahi Aditi, both of the balls will have different speeds now. Let's see. Mu square by 8L. Okay, let's see. Look at the picture. This is a length L. The length of the string is 2L. That means this 2M will keep traveling, traveling, traveling. At some point, you'll reach here. That is when the string becomes tight. And this length of the string is 2L. So this angle will be sine theta. This will be 30 degrees. So this is also 30 degrees. Got it? So this is L and this is 2L. Sine theta is half. So just before the string becomes tight, if you look at the velocities, this is going with u. So this component will be u cos 30 and this component will be u sine 30. And when the string becomes tight, the tension force will be along the string. Since tension is perpendicular, to u sine 30, it is unaffected. So velocities will change only in the direction of tension. So perpendicular components are unaffected. That means just after when the string becomes tight, the picture will look something of this sort. This is just after. So this perpendicular component will be unaffected. So this guy will be u sine 30 only. But the other direction, it will become something like, let's call it v dash. And why will both be equal? Because the string is tight, rigid string constraint. Since the string is tight, they should have same velocity along the string. Great. So I can choose anything as x-axis, anything as y-axis. So I'll conserve momentum along the string. So if you conserve momentum along the string, then in this direction, initially m is not moving, only 2m is moving. That will be 2m u cos 30. That will be 2m v dash plus m v dash. So we get v dash is equal to, m will cancel, 2u by 3 cos 30. Cos 30 is root 3 by 2. 2 will go off, you get u by root 3. Check. That means m will go with u by root 3, whereas 2m will go with v dash and u sine 30. So that 2m will have two components of velocity. Please have a look at the picture. Now the second part of the question. Find the tension in the string. So once the string becomes tight, what will be the tension? Any doubts on this page? Please ask me. Have a look at this. Let me ask you this thing. How do you think the motion will happen? Forget about the tension. Once you throw this, how do you think the motion will happen? Did you guys see this thing in movies and all they show, right? Someone is running away and the hero, right? Hero or the villain, whatever, they have this kind of the ball kind of things. They rotate, and they throw it up. And when you're running, right, these things will come and hit your legs and they just tie up and then you fall down. Seen this kind of thing anywhere? In movies, you must have seen. So if you look at the motion here, tell me one thing. So the 2m will go in some weird motion, m will go in a weird motion, their velocities will keep changing, but there is one point whose velocity will not change. Can someone tell me which point is that? M and 2m ka speeds will keep changing, velocities ka directions will keep changing, but there is one point which will not change its direction. Center of mass. Since F external is 0, the center of mass is unaffected. So if you look at the motion here, this is 2m. Initially the string was loose. This was m. The center of mass will be here, closer to 2m, at a distance of L by 3. The center of mass will go with the speed of v c/m. This will continue to go in a straight line. This is the path of center of mass. Since F external is 0, center of mass, velocity of center of mass is constant. Meaning that point will keep going in a straight line and these two will rotate in such a way. So if you look at the motion here, after when the string becomes tight, this will be the center of mass. After some time, if you look at the picture, 2m will come here, m will become like this, but the center of mass is still this. You're getting how the motion is? So these two are going into respective circles. So if you look at the motion of m and 2m, they are going into different circles. Are you guys able to visualize the motion there? The center of mass will continue to go straight line. The center of mass doesn't care about these two. And these two are rotating about the center of mass. This thing has become like this problem, if you remember. Which one? The first problem we did. Ye problem yaad hai? The rod is thrown into the air. Something of that sort. So, but this time the center of mass is going in a straight line. Clear with this? So once you got this, and what are the velocities? Remember, this was u by root 3. This was u by 2. And this was u by root 3. So what is angular velocity? You can clearly see, if you stand on m, you will think the angular velocity is, so omega is simply relative velocity. Think about this. If you go and stand on m, what will you think? You will think 2m has only u by 2 ka velocity, isn't it? With respect to m, you will think it is going with u by 2. So omega is simply the relative velocity perpendicular to the line joining them. By distance between them. So basically V tangential by distance. So that will be u by 2 by distance is 12. This is your omega. Then it is going in a circle. So it is going in a circle with respect to what? With respect to the center of mass. So you have to be careful with that. So if you go and stand on the center of mass, now the forces will be tension. And since you're going in a circle, there will be a centrifugal force, which is 2m omega square radius, which is L by 3. You could have taken the other string also, other block also, you would have got the same answer. Therefore, tension will be 2m omega square, the radius is L by 3. Omega will be u square by 16L. L by 3. L gets L square. 1 L goes off, you end up with mu square by 24L. Have a look at this. Is this making sense? How did you get omega? Because if you see, u by root 3 will not create rotation. Who is creating rotation? U by 2. So u by 2 by distance between them, which is 2L, will give you the angular velocity. But you're going about a circle about which point? You're going in a circle with respect to the center of mass. 2m goes in a circle with respect to center of mass, not about any other point. There is another reason also. If you stand on the center of mass has constant velocity, right? So there'll be no pseudo force. Are you getting it? Standing on the center of mass is an inertial frame because it's going with a constant velocity. So there'll be no pseudo force when you stand there except for the centrifugal force. Clear with this? It's a good one. I hope you can see how much we are connecting that circular motion, tensions, and everything. These are some really good problems, these last three, so you should definitely make sure to try them again. Any doubts on this? Anyone not clear with anything, velocity or anything? Clear, na, Samyak? Ishman? Clear? Ovia? Anvita? Shaurya? Great. Next one.
Sir,
Yeah.
sir, if we did this question like the last question you mentioned, we sat
What is
on
that last?
M.
Okay. Then M will be accelerating, na? तो उसका भी pseudo force लगेगा. You will
Yes,
get an
so
answer.
वो पीछे T का pseudo force लगेगा ना सर.
Yeah. इसका
What
होगा ना centripetal acceleration omega square 2L by 3. If you apply that, you'll get the answer.
डायरेक्टली हम 2m पे 2t का pseudo force नहीं लगा सकते क्या?
2T का pseudo force. What is 2T का pseudo force?
मतलब m पे t फोर्स है अभी.
Okay.
तो 2m पे मैं m पे बैठूंगा तो 2m पे 2t लगेगा फिर नेट फोर्स पीछे की तरफ.
You can't say that, right? God. T is equal to ma, na? A is T by M. Pseudo force कितना था?
ओ
2ma.
राइट. ओके ओके हाँ.
There's nothing called relative force. Don't create new concepts. Relative acceleration होता है.
No, I forgot that pseudo force is m into a, so मैं directly t minus कर रहा हूँ. t by 2 होना चाहिए.
Right. Next one. This is another standard question. Comes a lot. We'll again encounter this thing in simple harmonic motion, also in alternating current. So we got a block. You got a spring. 2m. Spring constant is k. We got a smooth floor. Spring is in natural length. So you kick this block with speed u, and 2m ka that is initially at rest. Find max compression in the spring. Find the maximum speed of 2m. Find the minimum speed of m. I think this lets us maximum speed of 2m. Let's get these two. Shaurya, give it a try. You can do yoga later on. Let's try the problem. Try, everyone. I gave you time to try and think about this. If you're just waiting for me to give the answer, you will not learn anything. Try, I'll give you a minute or two. This is a standard one. Matlab, it has come in mains and all a lot. Yeah. Just give it a try. See. Okay. Chalo, listen here. More than getting the answer right, should exactly know what is happening here. So initially, we have block M. We have 2N. So this is going with speed U. Since the spring is in natural length, there is no force here. This is at rest. Then what happens? Because M is going faster, it will get closer to 2M. The spring will get compressed. Since the spring is compressed, it will push you back with a force Kx, and this will push you forward with Kx. So because of this, what will happen? The speed will become V1, the speed will become V2. Now, because speed is pushing back, V1 is decreasing, and V2 is increasing. But suddenly velocities cannot change, so V1 is still greater than V2. So V1 is decreasing. It's like, numbers are like V1 is coming from 10, 9, 8, 7, and V2 is like 0, 1, 2, 3. They're increasing, but still they're not equal. At some point, as V1 is decreasing and V2 is increasing, both the velocities become equal. V1 becomes equal to V2. But still, if you observe, Kx is pushing backward, so V1 is decreasing and V2 is still increasing. So at this point, clearly observe. Next moment, what is going to happen? Next moment, 2M will go faster. That means spring will start opening up. So at this position, we get maximum compression. This is an important thing. So whenever they ask you maximum compression, you should know both the blocks have same velocity. Max compression blocks have same velocity. Then what will happen next moment? Remember, V2 is still increasing. The spring force is still compressed. So if you look at the spring here, spring is compressed, but it is opening up. Because 2m is going faster, spring will start opening up. That means here V2 has become greater than V1, right? And V2 is increasing and V1 is still decreasing. Then the spring completely opens up. Spring comes back to natural length. V2 and V1. So we can clearly see V2 has become greater than V1. There is no force. Now, if you notice here, at this point, V2 is maximum. Think about it. Next moment, spring will start elongating. At this position, V2 is max. Next moment, what will happen? The spring will start elongating because V2 is going faster. The spring is elongated. So what will happen? The spring will pull you back. The spring will push this forward, pull this forward. Remember, V2 is still greater than V1, but now V1 is increasing and V2 is decreasing. Now observe something here. Here V2 is increasing. Here V2 is increasing. Here V2 is increasing. Here V2 is decreasing. Means what? Increasing, 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 and then decreasing. Matlab this position your maximum, isn't it? Is that making sense? So you get maximum speed of the second block to the block when the spring reaches natural length again. Then you will again go to maximum elongation. This will be V2. This will be V1. At this point, V1 becomes equal to V2. The springs are again pulling back. This position, again, you get maximum elongation. So maximum compression, maximum elongation, the speeds will be same. Then next moment, you're still elongated. Kx is still pulling, right? So here V2, V1 becomes greater than V2. V1 is increasing and V2 is decreasing. And then again, you come back to the natural length. So this is a full cycle. This is state 1. This is state 2, state 3, state 4, state 5, state 6, state 7, and state 8. So if you see in this thing, we are more interested in state 1, state 3, and state 5. Do you guys remember we did something like this in work per energy? This is what I was saying. You should know exactly what is happening where. Please have a look at this picture there. So you should know what is happening with the block at any point of time. All got this? So once you got this, this is going with you and this is your natural length. This is your state 1. This is going with V. This is also going with V. This is your maximum compression. So at maximum compression, both will have same velocity. This thing you should know. If you don't know that statement, you can't solve. This was your state 3. This was V1 and this was V2. Again, this was natural length. This was your state 5 and this is V2 is maximum here. Perfect. So you want to conserve energy. So in all these cases, F external is 0. Therefore, momentum and energy are conserved. So momentum in state 1 is equal to momentum in state 3. Initial momentum mu, final momentum mv plus 2mv. V is equal to u by 3. Energy in state 1 is equal to energy in state 2. Initial energy, you have only kinetic energy. Spring energy is 0 because you're natural length. Gravitational energy is 0, you're on the same height. Final energy half mv square, half 2mv square plus half kx square. This is your maximum compression. This would be half mu square minus 3 by 2 mv square, which is u square by 9, is equal to half kx square. This 2 will go off everywhere. You end up with 2 by 3 mu square kx square. We have x max is equal to root over 2 by 3 mu square by k. Similarly, momentum in state 1 is equal to momentum in state 5. Mu is equal to mv1 plus 2mv2. Energy in state 1 is equal to energy in state 5. Half mu square is equal to half mv1 square plus 2mv2 square. There's no potential energy, spring energy, because it is 0. So if you take that v1, you want to find v2, right? So eliminate v1. Half goes off everywhere, m goes off everywhere, we get u square is v1 square plus 2v2 square. So from here we get u is equal to v1 plus 2v2. So if you substitute that, we get u square minus v1 square will be u minus 2v2 whole square. It's 2v2 square. Expand this, u square minus u square minus 4v2 square plus 4uv2. U square goes off, 1v2 also goes off. That will be 6v2 square, 4uv2, v2, v2 will be 2u by 3. Check. That is your maximum speed. Clear the steps, everyone. So main thing is to realize where you get the maximum speed, where you get the maximum compression. Without knowing that, you will not be able to solve. Clear? Any doubts on this?
So,
Go,
so
take
the
a break.
block will be like going opposite to its original direction, the other block, when this is
The block will go in the opposite direction. Yes. So it's like, if you see my screen, it is like this thing, it is like a caterpillar. It is oscillating and going forward. Able to visualize the motion? It's like this caterpillar type. It's like oscillating and it is also going forward. The blocks are oscillating and it is going forward. Right? Go, take a break. Come back in 5 minutes. We'll continue from here. Well, let's start off. Now, if this comes in the exam, right, it does take some time. So there's a faster way to do this. You can remember the result. It'll help a lot. Again, not a shortcut or something. You can actually let's say we have blocks M1, U1. This is M2. This is U2. Initially, if it is a natural length. So you can do the same thing, the maximum compression and everything. The final result will come like this. Half K X max square is given by half M1 M2 by M1 plus M2 V1 bar minus V2 bar ka square. U1 bar minus U2 bar ka square. So we write this thing in a shorter form. Half K X max square is half mu V relative square. This mu is nothing but M1 M2 by M1 plus M2. We call this thing a reduced mass. Again, this is not a trick or anything. When you solve this problem, right, assuming maximum compression will occur at, when the velocities are equal, conserve momentum and energy. Others, keep your cams on. And when you do that, you'll end up with this result. So this is called reduced mass because this whole system looks like as if it is single block and a single velocity. So half mv square is equal to half kx square. It kind of looks like that. So that's why we call it reduced mass. Quite a useful concept. This will come in again SHM. It will again come in atomic physics. That's the last chapter, modern physics. It will again come in gravitation. You will encounter this thing in 3-4 times. So reduced mass is an interesting one. And V relative is simply relative velocity u1 bar minus u2 bar. Should definitely mug up this result. Saves you time in the exam. Example. Now, if you just look at our previous question, so half k x max square is half m 2m by m plus 2m. V relative square is u minus 0 square. This would be mu square by 3. Half kx square. So we get x is equal to u into root over 2m by 3k. Same answer. U into root over 2m by 3k. Saves you time in the exam. Let me take one more example. Let's say this is 2m. This is 3m. Let's say this is going with 2u and this is going with 5u. Can you find the maximum compression? Try, I'll give you a minute. Just apply the formula. That is 3u. Find the maximum compression. Hmm. 6m by 5k. Let's see. Half k x max square. Half reduced mass is 2m. 3m by 2m plus 3m. Now be careful. V relative square. 2u minus of minus 3u ka square. V relative tha. And both are going opposite to each other. That will be 5u. That's what I said. It's u1 bar minus u2 bar. It is not magnitude of u1 minus u2. Clear with that. So I think that people goofed up. So be careful there. So x max square, the 2 goes off. That is 6m by 5, and that will be 25u square. This will be 30 mu square by k. Velocity ka direction matters. Yeah, right idea. All got this? Shman 2 nahi aayega re. Clear? It is not 3u minus 2u. It is 2u minus of minus 3u. Total become 5u. All clear with this? Next thing. So there, this will be a good shortcut. It will help you, right? Instead of conserving, doing everything, you can just finish off with this. Saves you some time. Let's say we have a block of mass m. This is another important model. Let's say someone is applying a constant force F. Now find the maximum elongation in the blocks. Maximum elongation this way. Initially blocks are at rest. How do we approach this? Think I'll give a minute, then I'll show you. There is only one way to handle this. You should know, like these are some kind of problems, where you should know the process. Listen. So in this problem, if you observe, first of all, there are a few things to notice. F external is not 0. Top of it, the block is also moving. Work done by external is also not 0. Therefore, momentum and energy, you can't conserve both of them. But there is something else to save you actually. If you observe, acceleration of center of mass is total force by total mass. This is constant. And I told you this few times. If you have a point which is going with a constant speed, constant acceleration, what do? We go and stand on that point, isn't it? In a system, if something is going with a constant velocity or a constant acceleration, what do? You solve with respect to that point. So here, we will solve with respect to center of mass. So take your observer and put him on the center of mass. So how do we solve? So listen carefully. So your center of mass is going with a constant acceleration. A is equal to F by 3m. So you're going to go and put an observer on top of it. So center of mass will come to rest. So if you ask this observer, what are the forces? He will say, okay, this thing has a force F. And since I'm a non-inertial frame, I have to apply pseudo force, which is mass of the body and acceleration. These are the pseudo forces. Then what will happen? Now see, he will think I'm at rest, okay? It feels like there is a fixed point. This block will move this side. This block will move this side. So, and if you remember, in a center of mass frame, the momentum is always zero. Means when this block comes to rest, this block also has to come to rest. So that the center of mass will be also at rest, isn't it? Think about it. If 2m is at rest and m is moving, isn't that mean center of mass is moving to the left side? But center of mass must be stationary because you're doing in the center of mass frame. So both the blocks will come to rest. So let's say in this process, let this thing travel x2. We don't know how much it goes. Let it be x2. In this process, let this block go x1. And what is the net force here? F minus 2ma. What is the net force here? Ma. So we are doing with respect to center of mass. So we use work energy theorem. So work done by external force plus work done by pseudo force is change in spring energy plus change in gravitational potential energy plus change in kinetic energy. There is no gravitational energy because they're on the same height. There is no kinetic energy because initially at rest, finally also at rest. If you see when the motion started, even then they're at rest. That means all the work done must have gone into the spring only. So what's the total work done? F minus 2ma into x1 so force into displacement, and this ma on the other block into, sorry, this is x2 is equal to, what is the total elongation in the spring? Think about this. If that block goes x2 and this block goes x1, then the elongation must be x1 plus x2. This is half k x1 plus x2 whole square. Take the Deka value and substitute here. How much is that? Ma is f by 3. This will become f by 3x2. This will become f by 3x1. So you will notice one thing here. Doesn't matter what values you will take, you will always get that x1 plus x2 whole square ka one term will cancel off. You end up with f by 3 is equal to half k x1 plus x2 whole square. So x1 plus x2, that's your max elongation. 2f by 3k. Check. This is the only way to do this problem. I couldn't find a second way to do this. So if you want to stand on the center of mass, we'll apply a pseudo force. Right? So
We
the
can
work
find
done by
x1 and x2, right?
yeah, you can find. You will argue like they will be in the ratio of 1:2 because they have to center of mass has to be at rest, na? So mx1 must be equal to 2mx2. That you can say. Clear with this. This is how you handle this. If you have an external force, you can't conserve energy, you can't conserve momentum. So we go and stand on the center of mass because it is going with a constant acceleration. We apply the pseudo force, we find the work done, and then we equate it to the energy. Check it out. It's a good model. Any doubts on this? For this also, we can make a shortcut, but shortcut is not really that great. You will there's a high chance you'll get confused and mess up. I'll show you anyways, but I though won't recommend shortcut for this, so better you derive only. The reduced mass because it comes in 4 chapters, it makes sense. Let's say we have forces F1 and we also F2. So we are taking them in the forward direction. Hey, we follow the same process actually. So center of mass will be here F1 plus F2 by M1 plus M2. And then we do work done and do all that stuff. You end up with 2 by K F1 M2 plus F2 M1 by M1 plus M2. That would be the shortcut for this. Example, if I give you like this is F and this is 2F. You can put a mod, basically depending on which one is bigger. Can you tell me what is X max for this? So be careful here. Since they're pointing forward, this is positive, this is also positive. If they're pointing in the opposite direction, you should put negative signs here.
So can we do this question using reduced mass?
Do it and tell me, no? So how to do this?
Sir,
2 by K. This
shall I
would be,
tell my method now?
you can send me the working, right? Why do you want to disturb the middle of the class, na? There are others also. So please be little considerate for others. Or you can wait at the end of the class. So look at this thing. This will be how much here? This will be F, mass is 2m. Did you get an answer with that? हाँ
Yes,
आर्या
sir.
आया क्या आंसर ठीक है that will be minus of just send me the snapshot and I'll check there. This is what we have to do. Because the 2f is minus here, it's pointing left. That will become how much? 2, 2, 4, 8 by 3. Eight f by 3k. Clear with that? So this is f1, this is m2, this is f2, this is m1. Any doubts on this? Like I said, I don't like this. I will derive it that will. I can derive this in a minute. So there's a high chance you will goof up something in the minus and in the formula, everything will go for a toss. Clear? Let's see one more. No. Let's say we have a plank of mass m. We have a person here of mass small m. Man of mass m jumps with speed u relative to the platform. This word is important, right? So suppose if they say the jump with speed u, that means they're talking in the ground frame. And we not see one thing. Oh yeah, you can always conserve momentum in the center of mass frame. Remember, there was a statement we wrote, because when you stand on the center of mass, momentum of the system is zero. Even if you have external forces, momentum is still conserved. And the floor is smooth. So with respect to the platform, he's jumping with you. Huh? So find the velocity of the platform after he jumps. Now, let me explain you a bit here about what do you mean by relative to the platform. If I simply say he's jumping with speed u, discussion closed. He's actually jumping with you. But if I say he's jumping with you related to the platform, the wording is a problem. Tell me one thing. When you're trying to jump, who is actually pushing you out? When you are trying to jump, there must be some force to push you out, isn't it? It is the friction between you and the platform, isn't it? That means in this process, when you're trying to jump, the platform is already moving. Just to give an example, think of like this. Let's say if I put you on a smooth surface, right? You take a book or something, and when you throw, if you look into my screen now, look at this thing. When I'm throwing this, it is not like, I will throw this and then I will go back. That doesn't happen. The moment I start this motion, I'm already going back. Are you getting what is happening? If I put you on a smooth surface, if I take something and if I try to throw, it is not like, this will leave my hand and then I will go back. The moment I start this motion of throwing my hand, as my hand goes forward, my body already starts going back to compensate. So that means when this person is about to jump, the platform is not at rest anymore. So when the man starts to move, the plank moves at the same time. When he is about to jump, platform is already moving back. That means when this guy is jumping, let's say if the platform is actually going back with V, This person is jumping. Look at that, means what? Look at his leg. When you're about to lose contact, your leg is also going back with v, and you're jumping with u. So you're actually jumping with u minus v. There. So when they use the word related to the platform, he's not actually jumping with you, he's actually jumping with u minus v. But if he tells you he's jumping with you, then it is fine. Matlab, in the ground frame, he's actually jumping with you. Clear with this? So let v be the Planck speed with the Planck speed when he jumps. So man ka actual speed is u minus v. I hope you're getting it. So keep that in mind. If you see HCV, in HCV, the question goes like this. The man jumps with speed u relative to the platform before he jumps. So before he jumps, what is the speed of the platform? 0. So with respect to 0, he's jumping with you. That means he's indirectly telling you jumping with you. So the word relative will matter. So you're not actually jumping with you. Now do this. Yeah, that it will be straightforward, right? So initially the whole system is at rest. So after he jumps, the platform is going back with v. The man is going with u minus v. So this is after jumping. This is before. Consideration of momentum. This is initially momentum is 0. This will be m into u minus v minus m into v. So v is equal to mu by m plus n. Easy? Yeah. So let's do another variation of this. Let's say this time there are two people. Capital M. There is person A, small m. There is person B, his mass is also small m. So here they're jumping one after another. So A jumps first, then B jumps. A and B jump one after another. With speed u relative to the platform. Find final velocity of the platform. after both jump. So first A will jump, platform and B will go, then B will jump, then the platform will go. So that is the final velocity. One after another, you have to conserve momentum twice. What do you get? Minus mu into 2m plus m by, it's difficult to type. Let's see. So first A jumps. So when A is jumping, you can treat B and the plank as one system. Let the speed be v1. And this person jumped with u minus v1. Conservation of momentum, initially 0. Finally, m into u minus v1 minus m plus m into v1. Remember, B is still standing, so they both are going together. So v1 is mu by m plus 2m. This is the velocity of the plank. Now B is about to jump. Now forget about A. A is gone. So when B is standing here, they are going with v1. Now when B jumps, let's assume the platform ka velocity became v2. That means B didn't jump with u, B jumped with u minus v2. Are you getting this? The velocities will always keep changing. They will always jump with the new velocity, with respect to the new velocity. This is the scenario after jump. This was before. Again, conservation of momentum. So initially the momentum will be m plus m v1 minus sign because it is going backward. This is a capital M v2 for the plank, and this bk is m into u minus v2. So let's get v2 from here. So v2 will be mu minus m plus m v1 by m plus m. So this will be mu by m plus m minus v1, which is mu by m plus 2m. Check. That will be your answer. Take it out. Stay with us. So that's a little about jumping and everything. So same thing, there is another variation of this. So instead of jumping, right, they can ask questions like this also. They will say there is a platform and there is a cannon. So inside this, we have a cannonball of mass small m. So this is fired with speed u at an angle theta. Is fired with speed u relative to the platform. They will say something like this: is fired with muzzle speed u. They will use this terminology. Muzzle is actually, if you ever seen a gun, right, the starting part of the gun, right, the ending part, when the bullet leaves, that thing is called a muzzle. Basically, it is same thing only, u relative to the cannon. Just a terminology there. Find the velocity of the platform after firing. So this velocity rate after firing, when the platform actually starts going back, this is called a recoil speed. Recoil, this is the speed which comes because you're firing the gun ahead. Same story here. So when you're firing again, remember, this is the u with respect to the platform. So after the firing is done, the platform itself is going back with v. So this cannonball which you fired will have vertical component u sine theta, that will not be affected, whereas the horizontal velocity becomes u cos theta minus v, isn't it? So this cannonball will actually fly with a different angle. So that also they can ask you. So even though it looks like you're firing with theta, the angle actually changes. Then you're done. Conservation of momentum initially is 0, then this will be minus mv. So it's just like man jumping from a platform, but you take only the horizontal component. So all these problems are same type. Man jumping, firing, and everything. So this is your recoil speed. Just be careful with the words because they'll ask you like this one, find the recoil speed, and you'll not understand what they're asking. Clear with this? there. So that's a bit about momentum and all. So next class when we catch up, we'll continue from here. We will be starting off with collisions and impulse, right? So we did some really good problems today. So make sure to go through the notes, right? Revise them once, resolve them again. That would be the best thing to do. Okay, with that we'll wrap up for the day. I'll see you guys again Tuesday, same time. We'll continue from here. So any doubts, anything else, please stay back and ask, or else you're free to leave.